Hi everyone! Today we're going to be talking about multiplying and dividing rational expressions. Our objective for today is that students will be able to simplify rational expressions. Let's get started. So first of all, what is a rational expression? A rational expression is a ratio of two polynomial expressions. So a rational expression is a ratio of two polynomial expressions. To simplify a rational expression, the first thing you want to do is factor everything that can be factored. So always factor first. Then we want to simplify the monomials using exponent rules. Last but not least, eliminate common binomial factors. And then your rational expression is simplified. Let's walk through a few examples. Alright, so number 1. First thing we want to do is factor out everything that can be factored out. So we want to first look for a GCF, right? Our golden rule of factoring is always try to take out a GCF first. So 20x to the 6th and 14x squared both have something in common that we can take out, 2x squared. So what we would want to do is take out 2x squared from both the top and the bottom. So if we take out 2x squared on top, we're left with 10x to the 4th. And if we take out 2x squared on the bottom, we're left with 7. Now, remember, anytime you have, say you have 5 over 5, right? Or 5x over 5x. These can cancel each other out because it just equals 1, right? If we have 5 over 5, that equals 1. 5x over 5x equals 1. So anytime you have a monomial over itself, it cancels out. So in this case, 2x squared and 2x squared cancel each other out. And we're left with 10x to the 4th over 7. And that is our simplified rational expression. All right, number 3. First thing we want to do is try to factor everything that can be factored. Y plus 8, our numerator, what's on top, we leave it alone. Can't factor that out any further. Our denominator, y squared plus 2y minus 48, is a quadratic expression, and we can factor this out. So we want to factor it out using our diamond method. So we want to put negative 48 on top, 2 on the bottom, and we want to look for two factors that multiply to negative 48, add up to 2. That would be 8 and negative 6. So our two factors of our denominator are going to be y plus 8 and y minus 6. Now we want to put y plus 8 on top, all right, because that stayed the same. We didn't factor it out any further. And step 3, we want to eliminate common binomial factors. So when we have two binomials, we have y plus 8, y plus 8. They're exactly the same, so we call them common binomial factors. They cancel each other out, just like the 2x squared over 2x squared in the previous problem cancels out. We can also cancel out common binomials. So y plus 8 and y plus 8, they cancel each other out. We're left with just 1 on top, right? Because when it cancels it out, what that means is we have 1 on top. We can't have nothing on top. We have to have a 1. So our final answer is 1 over y minus 6. Because the y minus 6 is still there. It doesn't cancel out. This would be our simplified rational expression. All right, number 5. We've got p squared minus 49 over 7 minus p. So we can see that the top, p squared minus 49, this would be difference of squares because we've got p squared minus 7 squared. So p is our a, 7 is our b. All right, so we've got p plus 7, p minus 7, all over 7 minus p because that stays the same. Now, something I want you to watch out for is anytime you have a minus b over b minus a, this will always equal negative 1, all right? In this case, we've got p minus 7 over 7 minus p. This is a minus b over b minus a. So we would simplify this to be negative 1. All right, something I want you to add into your notes as well is anytime you see A plus B over B plus A, this is always going to equal positive 1, all right? And this is an important thing we need to know as well. It doesn't apply to this problem because here we've got A minus B over B minus A. But anytime you see A plus B over B plus A, know that this always equals positive 1 as well. All right, so these are both very important facts that we need to know when we're simplifying rational expressions. All right, so back to number 5, back to our problem. This simplifies to negative 1, so we've got a negative 1 in our numerator on top. All right, so when we're simplifying this, we say that it's negative 1 times p plus 7 because that's what's left over. Now you have to distribute the negative 1 to both terms, so our final answer is negative p minus 7. And you're done. All right, number 7. So number 7, the first thing we want to do is take out a GCF. So both our numerator and denominator have 2 in common. We can take out a 2. So if we take out 2 on top, we're left with 3n squared plus 4n plus 1. And on the bottom, take out a 2 and you're left with n squared minus 1. All right, so our 2's are going to cancel out and we're going to be left with 3n squared plus 4n plus 1 over n squared minus 1. Now, our numerator, we need to factor, and because a is greater than 1, we have to be careful when we're factoring here. So we want to do our diamond, and we want to multiply a and c together, and we get 3. And then our b is going to go on the bottom, so 4 goes on the bottom. We want 2 numbers that multiply to 3, add up to 4, and that would be 3 and 1. Now remember, when a is greater than 1, when we've got a number in front of the n squared, we have to group factor. So we put our first term, 3n squared. Then we're going to put these 2 numbers in between, plus 3n, plus 1n. And then we put our c at the end, so plus 1. All right. Now we want to cut it in half. Take out the GCF of the first 2 terms, which would be 3n. We're left with n plus 1. GCF of the second 2 terms would be 1, n plus 1. And our 2 factors would be 3n plus 1, n plus 1. So that's going to go on top. We've got 3n plus 1, n plus 1. Now our numerator is difference of squares, right? We've got n is our a, 1 is our b. So on the bottom we've got n minus 1, n plus 1. Now, n plus 1 and n plus 1, we cancel out our common binomial factors. And what we're left with, scoot it up a bit, what we're left with is just this right here. So our final answer is 3n plus 1 over n minus 1. And that's our simplified rational expression. All right, now that we know how to simplify rational expressions, let's talk about multiplying rational expressions. So when we're multiplying rational expressions, if the problem contains monomials only, then we just multiply together straight across and then simplify using exponent rules. If it contains binomials or trinomials, we first want to factor everything out, then simplify, all right? Because once we factor, we can cancel out common binomial factors. All right, let's go through a few examples of this. All right, so number 9, we've got monomials only. Even though they are pretty complicated, these are monomials. All right, so what we want to do is multiply straight across. So multiply the numerators together first. So on top we get 60 x to the 5th, because we're adding our exponents together, all right, and y to the 7th. All right, these are our exponent rules. Then in our denominator, multiply straight across. So 2 times 18, 36. X squared, there's no other x's, so we're just left with x squared. Y squared times y squared gives us y to the 4th. All right, then we want to simplify everything together. So simplify the 60 over 36. Divide the top and the bottom by 12. We get 5 over 3. Simplify the x's together, all right? Since we've got x to the 5th over x squared, exponent rules, we want to subtract the exponents. So we get x to the 3rd. Y to the 7th over y to the 4th, subtract the exponents, and you get x to the 3rd. Now, anytime we've got positive exponents like this, these are going to go in the numerator because it's over 1. So we want to rewrite this together as one rational expression. So we would rewrite this as 5x to the 3rd, y to the 3rd, all over 3. And this would be our simplified rational expression once we're multiplying them together. All right, if you're having trouble with this, if you're just not understanding it, please raise your hand so I can come over and help you. Otherwise, let's move on. All right, number 11. Now we've got some binomials and trinomials. So the first thing we want to do is factor everything out first. All right, so first thing we want to do is look for GCFs. Do any of these have GCFs? And the answer is yes. So for our 4x squared minus 4x, we can take out 4x. And we're left with, let's see, x minus 1. Our denominator, all right, down here, we can take out a 2. And we're left with x squared plus 2x minus 3. Let's see. Here we just leave it alone. X squared plus x minus 6. Can't factor anything out. But then on the bottom we can take out a 4x and we're left with x plus 2. All right, now we want to factor these trinomials out. All right, so we want to use our diamond. We want two numbers that multiply to negative 3 add up to 2. And over here we want two numbers that multiply to negative 6 add up to 1. All right, so let's start with this one right here. So two numbers that multiply to negative 3 add up to 2, 3, and negative 1. So on here we get x plus 3, x minus 1. Over here, now we're going to this trinomial. Over here we get 3 and negative 2. So our factors here are going to be x plus 3, x minus 2. All right, remember there's nothing in front of this x squared, so that's why we just take these two numbers, write them with our x. All right, now if we want to rewrite this, all right, so it looks a little more neat, all nice and simplified. Copy the 4x times x minus 1, rewrite this denominator with our factored out binomials. Now going to this side over here, we want our x to the 3rd, we want our x to the 3rd, x minus 2, or x plus 3, x minus 2. All right, that's our numerator, and our denominator stays the same. All right, so there's a lot of factoring involved here, a lot of simplifying. All right, now before we combine everything, we want to look for common binomial factors in the numerator and the denominator. So here we've got an x plus 1 and an x plus 1. We've got common factors in the numerator and denominator, so these will cancel each other out. Then, over here, we've got x plus 3, x plus 3. All right, even though they're in different fractions, different rational expressions, that's okay. They can still cancel each other out because when we combine them, they all go together under one rational expression, all right? So these will cancel out. Then what else can we simplify? We've got a 4x and a 4x. Those are going to cancel each other out as well. All right, and then what are we left with? We're left with this x minus 2, this x plus 2, and this 2 right here. So we can't simplify those any further, so we just write them under one simplified rational expression, x minus 2 over 2 times x plus 2. And this is our final answer. We went from this super complicated one up here to this simplified rational expression. All right, so always remember, factor everything you can first, then multiply together, simplify, eliminate common binomial factors, get it to be as simple as you can. All right, now let's talk about dividing rational expressions. So dividing rational expressions is just like when we're dividing fractions, all right? We can't divide by fractions, but we can multiply by the reciprocal. Reciprocal, all right? Not an easy word to spell. Okay, so dividing rational expressions, take the second rational expression, flip, and multiply. Let's go through a few examples. All right, so just like when we're dividing fractions, we can't do it. Same with rational expressions. We can't divide rational expressions, but we can multiply by the reciprocal. So take, oops, I want my pen. Take the second rational expression, flip it, and multiply. So copy the first one, exactly how it is. Some of you may have learned this as copy, change, change, right? Same thing. Copy the first one, change the sign, flip the second one. All right, flip the second rational expression. Copy, change, change, flip and multiply. However you learned it, use some sort of way to help you remember. Flip the second one, multiply. All right, now we're just multiplying straight across. It's just like multiplying rational expressions like we went through in the previous examples. Multiply the top together. So we get 40p q to the 6th over, multiply the bottom together. We get 560 p to the 5th and q squared. Okay? Now what we can do is simplify. So we can simplify first the 40 divided by 560. 40 will cancel out. You're left with 16 on the bottom if we divide the top and the bottom by 40. All right. Then p, we've got 1p on top, 5 p's on the bottom, so we get 1 over 16, p to the negative 4, and then our q's we get q to the 4th. All right, now because p is negative, that means it's going to go on the bottom. Because q is positive, that means it's going to go on top. All right, so when we rewrite this as one simplified rational expression, we get q to the 4th on top, divided by 16 p to the 4th. And that's our final simplified rational expression. All right, last but not least, number 15. So we've got dividing. We're dividing rational expressions. Can't divide, so we want to flip and multiply. So first, copy the first one, 2a to the 3rd minus 12a squared over a squared minus 4a minus 12. Change the sign, flip the second rational expression over 24a squared minus 8a to the 3rd. All right, so this is always our first step because we cannot divide rational expressions just like fractions. You have to flip and multiply. Now we want to factor out what we can factor. So the first one we can factor out a 2a, and we're left with a minus 6. The bottom, we want two numbers that multiply to negative 12, add up to negative 4. Those two numbers would be negative 6 and 2. So on the bottom, we've got a minus 6, a plus 2. Then over here, all right, now we're still multiplying. Now on top, we want to factor this out. So we want two numbers that multiply to 15, add up to negative 8, negative 5, negative 3. So here we've got a minus 5, a minus 3. And then on the bottom, we can factor out an 8a squared. And we're left with 3 minus, or let's see, hold on. Yeah, 3 minus a. Okay, so now we want to simplify what we can. So we've got a minus 6, these are going to cancel out. Now here, we've got a minus 3 over 3 minus a. This is our a minus b over b minus a, and we know this equals negative 1. So this is going to cancel out and give us negative 1. What else can we factor out? So we've got a 2a and an 8a squared. We can divide everything. We can divide both of these by 2a. So 2a is going to cancel out, and here we're going to be left with 4a. And that's as much as we can simplify. All right. And you know what? I think I made a mistake over here. Hold on. This should be a 2a squared. So therefore, the a cancels out here, and the a is going to cancel out here. So we're just left with a 4 on the bottom. I'm sorry, my bad, but I caught it, all right? Then, what are we left with? We're left with a plus 2. Oops. We're left with a plus 2. We're left with a minus 5. We're left with a negative 1, and we're left with this 4. Now, I know this gets messy, so be careful. Then we want to rewrite what we're left with. So on top, we're left with negative 1, a minus 5. On the bottom, we're left with 4a plus 2. Okay, now we want to distribute the negative 1 to both of these, but we want to leave the 4 factored out. We just always want to distribute negatives when we can. So negative a plus 5 over 4 times a plus 2. And that's our final simplified rational expression. All right, so I hope you learned a thing or two about simplifying, multiplying, and dividing rational expressions today. Please look to the board to see what to do next, and I hope that you have a great day.